Hi, it's Mrs. James here. I'm just thought I'd make a quick video about the ant simulation skeleton code for this year's AQA Computer Science Paper 1. It's just a whistle-stop tour. There are much better videos talking through the coding side of it on YouTube that you can go and find. But this is, from my perspective as someone who's taught this and marked this for about 5 years, just to give you sort of maybe some quick tips. As you will know, the skeleton code is asked about in section C and D of paper 1. And looking at the electronic answer document, we can see there are 4 questions in section C, which is theory, with these marks on it. And 4 questions in section D on the programming side of them. As you will see, there are some very high tariff questions in there. So it's really worth getting your head around the ant simulation, practicing programming it, practicing tweaking it so that you can take advantage of it. If you look at the front of the paper, you will see that it suggests you spend 20 minutes, I think, on section C and 70 minutes on section D. So altogether, that's over an hour and a half of your 2.5 hour paper on this ant simulation skeleton code. So you really do have to look at it, all right? If your teacher hasn't given it to you, then you really need to be banging on their door and making sure you've got hold of it. The zigzag resources are, again, really good. I haven't had a vision of much of it, but the bits I have seen, kind of tally with what I would expect. Okay. If you want a good visualization of what the heck this ant simulation is about, there is this, I'll put it as a link to the video, there is this simulation here. It basically shows how ants over time from a food source will make trails using pheromones that the other ants can follow to go directly to the food source. It's quite a nice little activity that you can kind of play with it if you don't really understand what the simulation is doing. My overall tips: don't expect to finish. Okay, this is sometimes quite reassuring because some exams, you generally would finish it and then you have plenty of time to go back and refine your answers. In this one, not so much. If you it's very, very rare for marking complete exams. So come up with some strategies as to how you can just maximize those marks. Please spend a significant amount of time reading and understanding the skeleton code and the preliminary material. So you've got as much advantage of when you walk into that exam. So you've got as much knowledge about this code as possible. Consider feeding the code into an LLM and getting it to explain parts to you that you don't understand. That has been quite helpful this year. Just so that, if there are particular bits that you can't quite figure out, an LLM might be able to explain it better to you. Please do get used to using the IDE, the development environment you're going to be using in the exam, so that you're quick at searching for code, searching for functions. Know where those things are within the 400 odd lines of the skeleton code. You don't want to be clunkily taking your first steps in VS Code or PyCharm if you've only ever been used to using idle. So find out what you'll be using in the exam. It makes a bunch of difference. And if your teachers are only getting you to use idle in the exams, you're missing a massive trick, because things like VS Code gives you loads of help to suggest functions, to suggest, spelling mistakes and things like that. And that's all completely within your rights within the exam. And because this is object-oriented code, make sure you are happy with what classes are in there, what are the child classes and how they're related. Revise your OOP terminology, because there will be tons of questions on it. 2017, which is almost 10 years ago, had some very similar skeleton code about modelling foxes and rabbits and how their populations changed over time. I'll put the links in the video, but it's quite good to get an idea of what sort of questions they could ask. Make sure you understand what classes there are, what their attributes and what their methods are. I've just put a screenshot of a little bit of research I did on this. We can look at that later. Make sure you understand that when it creates a simulation, there are a bunch of starting parameters that are in there. Hopefully you've seen that. It's quite easy to see to start with. Here are Mrs. James's top tips for what are potential theory questions. I make no guarantees, but this is my, if I was a betting woman, these would be what I bet would be in the exam. Here are some tips, though, for answering those theory questions. If you're asked to state an identifier, e.g. for a class or a method or an attribute, just write the name, okay? Don't put any brackets after it or stick any parameters or any extra code, just the name. In previous years, we have docked marks if people have been foolish enough to put brackets at the end of, say, a method name. So don't do it. Do make sure you know the differences, in theory, the differences between a public, a private, a protected method or an attribute, and be able to explain it, because they like asking questions on that. Be able to describe what polymorphism is. Now, this video isn't for me to explain what those things are, but these are to highlight things that you'll probably be asked about, so go off and revise them. Because there are lots of classes in this simulation, there's an entity class, which then has child classes of pheromone, ant, nest and cell, which inherit from it. And then underneath the ant class, you also have a queen and a workaround. Okay, so there might well be a labelling a diagram question. That's what happened with the foxes and rabbits. So make sure you know what it looks like. If you're asked to draw arrows, which is unlikely in an electronic answer document, but make sure you know which way the arrows go, and the fact they're hollow arrowheads like that. You might have a question on the fact that the entity class is an abstract class, i.e. it should never be instantiated and only ever inherited from. So make sure you're aware of what an abstract class is. Now, there's also in the spec this idea of composition and aggregation as other ways of relating different classes together. There hasn't been any, I think, other questions of it that I could find. So this year might be a first. There's already been quite a lot of discussion online about which is composition and which is aggregation. And my summary is that the simulation class doesn't have any inheritance, but the pheromone, ant, nest and cell classes are related to it by composition. Go away and look up what it means by composition. And that's how you would draw the diagram with those filled in diamond arrowheads. But then there is also the idea that an ant and a nest is related using aggregation, which means that they have a relationship, but they, unlike a composition, because, for example, if we deleted the simulation object, all of the pheromones and ants and nests and cells would be gone, whereas an ant and a nest have a much more loosely tied coupling, which is called aggregation. So if you delete an ant, it doesn't delete the nest, and vice versa. Make sure you're happy with some OOP definitions. They don't often come up in Python because we don't really use them in Python, but the idea of an abstract class, abstract method, and a virtual method, they're on the spec, so you are expected to be able to define those. There's also a sneaky little class, it's called a static variable or a class variable. This is from Python. The next ant ID is within the ant class, but it's kind of like used in this case as a global count of ants, and it allows us to give them unique IDs. Okay, it's not tied to any one particular instance. It's tied to the whole class itself. So you might be asked to identify a static or a class variable in the code. Also for theory, you might be asked to design a new class, not code it. I've just got a screenshot of the code, the question and the mark scheme up here. So you're not expected to actually write this in Python or C#, but you might be asked to design it. So have a read of that. This could be, design a new ant class. And here are my take on potential coding questions. If you've got the zigzag package, then I think there's like about 15 different ones that they've come up with. Some of them are good. I think, some of these overlap with my ideas. There's definitely going to be a validate question in there, that 5 mark. Do you remember I said there was like a 5 mark question in there? This has come up again and again in exams. The first question is just a validate input. There's a bunch of times where within the program, it's asking a user to type in a number or a letter. And if you type in something that isn't that, it fails spectacularly. So have a go at validation. You might be asked to add a new simulation size. I think currently there are 4 in there, 4 different types of simulations, but you might be asked to add a new one, but also then ask the user to perhaps input the size. There's a whole bunch of like knock-on effects of that, so I'm less sure that that's going to happen. Originally, I thought you might be asked to display it as a grid, but I'm now thinking that would be far too difficult and far too likely to break. If you've got time, you might want to try and change it so it displays it as a grid rather than a long list. But I doubt that will happen in the exam. I've also noticed that food cells could spawn on top of each other, so that might be another bit of validation you could add. You could spawn a nest in a random position. Currently, there's already a nest always at 2, 4, row 2, column 4. There might be something to do with pathfinding. Could that be improved? I'm not sure about that one. There might be a way of adding obstacles. In the foxes and rabbits one, you had to add a river, and the rabbits couldn't cross the river. So that might well be something to look at. I think there's definitely going to be adding a new class, flying ants, birds, forage ants. There's also the queens don't move currently, so that might be one. Here's an example of some validation. So you can validate the choose simulation errors if you don't choose 1 to 4. So there's a little bit of an example of my Python validation in there. Try and understand how this get index works. This could be asked in section C. Basically, the grid is a 1D array, but when you look for a cell or an ant, you type in a row and a column. So get index, there's a little bit of explanation there. Get index converts that 2D array, row and column, into a singular index for where it is on the grid. There's also the get indices of neighbours. This will return a 9-element list of the neighbours around a particular cell. So you give it a row and column, and it will return a 9-element list with any invalid neighbours represented by a -1. Pheromones, I was a bit unclear about how pheromones worked, but each ant only has 1 pheromone per cell, but each cell can contain multiple pheromones from different ants. Not quite sure how this would work in coding, but again, this could be a theory question. There isn't a way of counting the number of queens in a nest. I thought this might be an idea. So in this example, you've got count how many ants are in a nest, but I added how you could count the number of queens in a nest. In a queens in a cell. I don't know, might be useful, might not. One of the things to think about when you're doing these programming questions is there's a lot of helper code already in there. So if you're thinking, I don't know even where to start, if you know that code pretty well, you could probably go, it's kind of similar to counting the number of ants in a nest. Copy and paste that and just change bits. There's no rule against that. Understand the change cell method in an ant class. So you're given, with change cell, you're given the new cell indicator, which is either do you want to go up or down or left or right, and then the row and column to change. And it basically will move your current cell to the left, to the right, diagonally, or diagonally. So that could be a question again that's asked, or something that you use in your coding activity. I think I said this before, queens never move. The class never overrides that choose cell to move to method. So it could be a good question where you implement it, or it could be a theory question to discuss overriding, or potentially whether that ant class is still technically an abstract class, because it doesn't override, and you could discuss that an ant class is an abstract class because it has this choose cell to move to, which it's expecting all child classes to override. Something that could be quite easy is create a count for the number of stages. I might be running out of time here, so I will just leave that one on the screen. show the message to appear when all ants are dead. Currently, you can run your simulation 1,000 times and it still keeps running, even when you inspect it and all the ants are dead and nothing is ever going to change. So I think this is likely to happen. This sounds like quite a nice thing to do. I haven't written this myself, but it is definitely in zigzag. And I've just summarised it here. Add some new attributes in your simulation, a Boolean, simulation ended, a piece of text that says end reason, and then add some new functions to return true if there's no more food or no more ants, and a reason that is one of the two. I like this. I'm getting a good feeling about this one. So do have a little bit of a play and see how you might end the simulation. And then almost certainly there's going to be adding a new class. This is my own take on adding a flying ant class. It would likely to be overriding a current method. So I've got choose cell to move to, and I've got I made up some way of working out if you've got a flying distance of, I don't know, 10 cells, it goes and works through which cell to move it to. Please don't look at my code too much. This is me just making something up, but have a look at just the intro bit of making this new class, because be familiar with how you do it. The idea that you put the parent class in brackets there, you declare your init with whatever your starting parameters are, but then if you want to call the original ants init, you have to use this super function or object to call the init, and then you can add any extra things after it. If you can get that kind of syntax going in your class, you've got at least a couple of marks there, even if you don't actually get to do the moving or the clever stuff within the class. Like I say, please don't look too closely at this code, because I don't think it's very good, and it's completely different to how Zigzag do theirs. Just as a final point, I think the last question is likely to be a new class, and if you're running out of time, my tip is create some sufficient amount of code to get some marks for a new class. That won't break the program. Simply writing class flying ant will not be enough, because if you try to run your code, there'd be a big fat error saying, syntax error, because it's expecting, an actual official block of class data. So try and, I would say this is the bare minimum. Make sure you're inheriting from the parent class. Then make sure, even then, you could just put a parse. Are you all happy about parsing? That just basically means it just doesn't expect to find the rest of the method in there. You could do that inside the class and then potentially get 1 mark for declaring a class. Equally, you could get some marks for declaring your constructor here. You might even get another mark for calling the constructor of your parent class. You might get some other marks for setting the type of ant. And then if the question is asking for a particular new method, then why not define it? But again, you can put parse in there. I've also seen some students who forget to put self in there, and you don't get the mark for that. So, you will run out of time, but if you kind of do that, you could still get 2, 3, maybe 4 marks for your last question, which is as much as the evaluation section of your project would have got you. So anywhere that you can scrape 1 or 2 marks will be really helpful. Okay. The other tip to think about is that generally the grade boundaries for the AQA papers are generally lower than OCR. So even if you think you haven't done particularly well, you could still have done really well comparatively. Okay, good luck for June the 10th, and I will see you later.